Hello everyone, I'm Danny, and today we will continue to discuss OceanStor Dorado NAS, and our topic is multi-protocol access. Multi-protocol access means that both NFS and CIFS share are created on a file system, and clients use the two protocols to access directories and files at the same time. However, Windows and Linux systems vary in user authentication and file locking, so we need to take technical measures to adapt to the differences between the protocols, so that the user's access requirements are met. Multi-protocol access is a test of whether storage vendors have the technical strength to do a good job in NAS. This is because a storage vendor must independently develop NAS protocols to ensure smooth interoperability and mutual exclusion between NFS and CIFS share access. First, let's have a look at user mapping management in the multi-protocol access scenario. The multi-protocol access function must ensure the permissions set for one protocol also apply to the other protocol, so that file authentication can be controlled to maintain security of multiple protocol access. So we need to record the mapping between SMB users and NFS users, and this requires the user mapping management function. For example, assume that a mapping relationship has been established between user A on a Windows client and user D on a Linux client. Then, if you assign the read and write permissions of a file to user A, the storage system will find user D on the Linux client based on the user mapping and assign the read and write permissions to user D. In this way, user D on the Linux client has the permission to read and write the file. OceanStor Dorado supports two user mapping management modes. In the first mode, the storage device manages user mappings. SMB users can be local SMB users or AD domain users. NFS users can be the local NFS users or LDAP and NIS domain users. You can create user mapping rules on the storage device to associate SMB users with NFS users. A user mapping rule must contain the mapping type, user name, and priority. The mapping type can be from Windows to Unix or from Unix to Windows. If a user matches multiple user mapping rules, the rule with the highest priority takes precedence. You are advised to set the same name for the NFS user corresponding to an SMB user. In this way, you only need to configure one mapping policy for that name on the storage device for higher configuration efficiency. If a corresponding rule can be found during the authentication, a user will be matched as nobody on Linux or everyone on Windows, and the user will only have the minimum access permission in this case. In the second mode, an AD domain manages user mappings. The AD domain provides the NIS domain function, which requires the component called Identity Management for Unix, or IDMU, to be installed in the AD domain. The IDMU can map an AD domain user to a NIS domain user with the same name and synchronize the user password. You only need to configure the NFS user management function of the storage device as the NIS domain service provided by the IDMU. The second mode is suitable for scenarios with a small number of NFS users. In addition, if you use the second mode, the NIS domain service of NFS needs to be planned at the beginning. Therefore, the first mode is the mainstream. After configuring user mappings, we need to consider how to authenticate NFS and SMB users who attempt to access files and how to control the modifications of the file permissions. So let's turn to the security style. OceanStor Dorado supports 4 security styles, which are NTFS, Unix, Mix, and Native. Now, let's look at their differences. In the NTFS style, the ACL and file owner can be set and queried on a Windows client, but cannot be set on a Linux client. When a Linux client attempts to access a file, the ACL permission set on the corresponding Windows client will be mapped into the NFS v3 mode permission or NFS v4 ACL permission for authentication. That is, in the NTFS style, the permissions set on the Windows clients prevail, and Linux clients cannot set the ACL and mode permissions for files. In contrast to the NTFS file, the Unix style allows Linux to set permissions and owners, but does not allow Windows to do so. NTFS and Unix are the most commonly used security styles, but either Windows or Linux is mainly used to set permissions in a multi-protocol access scenario, and the two security styles will help simplify permission management. Mix and native are special styles. They allow both Windows and Linux clients to modify file permissions and owners. In the mix style, the permissions and owners set on a client will overwrite those set for the peer client. If there are multiple overwrites, the administrator may not know which client sets the permissions. Therefore, the mix style is not recommended unless the permission configuration is simple. In the native style, permissions can be set on both Windows and Linux clients. However, the storage device will store a copy of SMB permission data and a copy of NFS permission data separately. This prevents a mutual impact on each other's authentication. However, this also makes authentication management more complex. For example, if a user needs the permission to access a file from both Windows and Linux clients, the administrator must assign the permission to the user twice. Finally, let's go over how lock management is implemented in multi-protocol access scenarios. Windows and Linux vary in lock mechanism. To implement multi-protocol access to a file system, the SMB and NFS protocols that attempt to read and write a file at the same time must be able to lock the file for mutual exclusion and data consistency. To achieve this purpose, OceanStor Dorado provides a distributed mechanism called Multi-Protocol Lock Manager, or MLM. It has two functions. First, MLM uses a distributed algorithm to enable each controller in a storage cluster to manage some of the locks. In this way, all nodes participate in file locking and lock release, improving processing performance. Second, MLM converts the locks defined by the SMB and NFS protocols into unified locks, and then locks these files in the file system. In this way, lock mutual exclusion is implemented across protocols. Both SMB and NFS locks are classified into file locks and range locks. A file lock determines an application's permission for a file it attempts to open, such as read-only, write-only, and read-write. In addition, an SMB file lock allows users to set an exclusion mode. This mode indicates whether another application can read, write, or delete the currently locked file. A range lock only locks a part of the file data. Range locks are classified into read and write locks. Typically, files in virtualization and database scenarios are large, and a range lock is used if only a small amount of data needs to be read and written at the same time. According to the NFS v3 protocol, files are implemented by clients. That means clients will not deliver file locks to a storage device, and the storage device cannot sense the NFS v3 file locks. Therefore, we implement mutual exclusion between NFS v3, range locks, and other protocols' files locks. For details about the rules for lock exclusion across protocols, please see the following table. That's all for the multi-protocol access technology implemented by OceanStor Dorado NAS. I'm Danny, and see you next time.